Hello guys, today we are gonna trying to solve two questions which is related to your textbooks in the data and data, and so the 3.35 and 3.36 are solved in today. And so as previous in the lesson, we should create a Visual Studio project file in order to create a modeling based on the C programming language, because we should have the compiler and debugging session in order to run the specific codes in C programming language. And the Visual Studio 2019 gives us a specific way to create this kind of programming techniques. Okay, and so as previous in this lesson, and so we should create a new project. And so we should check the C++ compiler in here. C++ and C has the same structure in compiling session, but with some basic differences. And so you can use the C++ programming in here, and then we should select the console app session in here. Okay, and so we push the next button in here, and so we can choose the specific location related to what is or where is the R project is stored in our computer. Okay, and so I click the browse session, and so this is the week 3, and then I can select this folder in order to store the files related to my programming session, especially in the C programming language. Okay, and so the project name is the week 3, and the place solution and project in the same directory is checked, and then we can create this project. Okay, and so we have the basic solution in here. We have 3 lines or 3 sections, which means that we have a solution explorer in order to create a source file, and so we have a command window or editor in order to write a code in this session. But in our programming language, it's C, we should change the extension of these things like this one. Okay, and so we can create the basic code definition in here, and so we can give the int main function in order to starting address of this program. And so this program can be started by the hello world keys. Okay, if we run this program, we should use the Control F5 button, and so we have the debug console in here, and then we can check the hello world is written by the programs. Okay, so now we should turn into the question. And so the first question is relating to the printing the decimal equivalent of a binary number. And so what does that mean? It means that we have the decimal number like the 12 or 10 or 5 or 100, and so we need to convert it to a binary number form, which means that they are 1 and 0 representation of the decimal equivalent numbers. Okay, and so in our question we have some specific representation or the structure, which means that the input an integer, and so we need to create a integer variable, 5 digits or fewer, it doesn't matter for our program, and containing only zeros and 1. Okay, and so print its decimal equivalent. Okay, and so in the question it's given by these things, but in our question representation we will do it in the reverse direction because it's different, and so it says a solution manual, but in our lesson we have the decimal number in here, and so if we give the decimal number in our program, and then we will get, or we need to get, the binary number representation. Okay, and so in our programs we use the division and the remainder operator in order to create these things, because you don't understand now the array structure or the some specific function block related to the C programming language, because the C programming language can give you a way to create these things by using one single function block. But as an engineer, we should describe, or we should create a pattern to create these things by algorithms which made us, and so we need to create a mathematical representation of these things, and then we can convert it a decimal number into the binary one. In the question, the reverse is desired. Okay, and so in order to create this pattern, we should create some main function blocks, and so the basic knowledge can be reviewed in here. The include or sharp include, it's related to the pre-compiled definition or the codes, because it's related to the including the some specific libraries into our project or our code. Okay, and so this is only related to the include keyword is a preprocessor in the terminology. Okay, and the C preprocessor is not a part of the compiler, but it is a separate step in compilation process. Okay, and so in order to compile this program, this code is first reviewed or is first checked, and then this file standard input output dot header file includes our project, and then the compiler gives us a compile code related to these function blocks included in the standard input output function blocks. Okay, and so the include or define codes is related to preprocessor of our code representation, and so if we use these things, and then we can use the some specific function in the standard input output header file like the printf. Okay, and so the main function block is the starting address point related to the our program start execution point. As a reminder, as the whole programming language is run on the CPU, okay, or in the processing units in our computer, but the whole codes firstly creates or the converted into the RAM block addressings, because the whole variable or the whole codes needs to be converted into the binary code, but this binary codes firstly is stored in RAM, okay, in our computer. And so the main address or starting address is related to the RAM address of our programming techniques. Okay, and so in our computer, if we run or if we compile this program, and then the main is selected or is assigned to the some specific address point of the RAM. Okay, and then these program blocks run at the start or in the first place these code techniques. Okay, and so if we turn our main problem in here, we need to store integer number blocks, because we need to store the decimal number in here. And so we need to ask the user as to enter a decimal number. Okay, and then if we give these things, and so as in the previous lesson, we can use the scanf as function blocks in here. And so we need to give the type of these variable things, and then we need to address operator of the num variable. And so as you can see, we should use the address operator in here, and which means that if we put into the variable first or prefix position, and so this means that this address blocks gives us the specific address of or address point of RAM related to the num variable. Okay, and so the main and then num address operator is the same, but with in the different address positions, okay, in the RAM. And so we can run this program, and then the program asks the enter a decimal number points, which means that so like the 5. Okay, and so we put into the enter point in here, and so the program is done because there are any codes in here. And so in the first place we should define use these things, but in order to create a binary form we should store it as well. Okay, and so we can use the long variable bin is equal to 0. And so some people ask me why we use the different type of these things. For example, num is stored as a variable of the integer type, and so the bin is a variable of the long type. It's an opinion object because the binary things especially in our RAM is the 32 bits or the 64 bits. Okay, and so the integer number has a limited storage area or storage address points. Okay, but if you can use the long variable, and then you can store the higher number than the integer one can. Okay, and so we should use the long variable number in order to create a 32 bits or the 64 bits. Okay, because we have this kind of bits in order to write the whole these variable types. Okay, and so in order to split this num, or in order to convert this integer num value into the binary section, we should use some specific variables: reminder, integer, position in here, and step variable. In the first place we should assign 1. Reminder is used to splitting into this 1, because if we have, for example, assume that we give the 10 into the num number, and so we can split into the 2 parts. Okay, and so if we divide the 10 by 2, and so we have the 5, but the 5 is not not the reminder part of these things, and so the num variable or the 5 cannot be divided without the reminder terms. Okay, and so every number may have this kind of situation, and so the reminder should be created in here. Okay, and so is the step number, and so the step is related to the reminder and the division operator in here. In the C programming language, if we use this kind of operation or operands, which means that we can initialize the whole variable in the first place in the creation of these things. For example, if we use the integer num variable in here, but we did not initialize these things, and so the num has the garbage value in the first place. But if we use these things, and so it means that this num is initialized by the 0 variable. Okay, and so this is the basic difference between the num and e and step number in here. Okay, and so in order to create a specific task, which means that if we have the num variable in here, and so we can produce the binary number selection. And so in order to do that, we should use the loop variables like the while. Okay, and so if we split this num variable into the two parts or binary parts, and so at the end of this code, and so the num should be equal to 0, because we split all the things, and num cannot have any number variable if we use the correct steps of these things, or these things is done. Okay, and so in the first place we should store the reminder term like using the num2 2, and so in this code block 2 is used to what kind of reminder is in the num variable, like the 5 has a reminder of the 1. Okay, but 10 has the reminder of the 0, because the division is the exact in this kind of situation. Okay, and so if we use the percentage variable in here, this code gives us the reminder of these things. Okay, and then if we have this kind of situation, and so the num should be divided by 2, because in the binary selection we have the 0 and 1 value. In the decimal one, we can split the whole decimal number by using the 10, because in the decimal number the hexadecimal is a 16 value, or the decimal as 10, or hexadecimals or the octadecimals as the 8 units. But in the binary selection, whole things is creating by the 0 and 1, or so we should create a 2, or we should use the 2 value. Okay, and so what happened if we try to find the tree section 0 1 2, or the decimation of is related to the 3, and so we need to try to change these things with the 3 value. Okay, or in the decimal notation, and so we should use the 10 variable in here. But in our cases, the binary selection is related to the 2, and so we need to create a pattern by using the 2 integer value of the 2 in here. Okay, and so if we divide these things like this one in the first place, such as the, for example, if we have the 5 variable in here, and so the 5 divided by 2 is equal to 2, and so, and then 5 remainder by 2 is equal to 1, and so what does it mean? And then if we create a binary pattern, and so firstly we need to give a 1 variable in here, because it gives, or it comes from the remainder of these things. It's the first place of the first decimation of the binary strings. Okay, and so if we have the result of 2 comes from these things, and so we can write it down as the 0, because 2 over 0 is 1. Okay, and so if we have 2 in here, and so we need to create these things, and the 2 and 1 in here, and so in the first place we have the, for example, the 4 digits is stored in here, and so the 5 variable is directly related to these things. Okay, and so this number is created by the 3 0 times 3 over 3. Okay, and 0 times 2 over 3 plus, and so in this place we have the 1 times 2 over 2, and so 0 times 2 over 1, and so we have the 1 times 2 over 0. Okay, and so this comes from the idea of these things. The over things is determined by using this area of these things, and so we should put the one variable in here, and the remainder term is directly related to these things. Okay, and if we use the 4, or the our number is equal to 4, and so this remainder is equal to 0, and so we can write it down as this kind of situation, like this one, 0. Okay, 4 2 is equal to 2, and so the 4 percentage 2 is equal to 0, and so this is related to these things, and 0 is related to these things, and so the 0 must be assigned to this one. Okay, and so in each loop is doing in here, and so we get this number of terms. And then how can we update the binary number in here? Binary number must be updated by the bin plus ram times I. Okay, because if we have this kind of information in here, and so we can use these things by remainder times e is equal to 0, and then bin must be added in the first place. Okay, and so if we have this I value in here, and so e must be equal to e times 10, because the decimation number is 10. Okay, decimal number is equal to 10, but the binary is equal to 2. Okay, these are basic algorithms in here. Okay, and so in the last place we should write it down as the decimation is given in the integer form, and so we need to put the percentage d in here in decimal is equal to, the other one is LLD, long integer, and so in binary position in here, and then first we should give num, and in the second place we should give the bin variable in here. Okay, and so we should create this pattern, and then we can try these things like this one. So we can, now we have the 5 variable in here, and so 5 0 in decimal numbers in here with the 1 0 1. Okay, and so in order to num printf value should be added in here, because the num print is print, so we should add this time. Okay, because the num is going to 0, but in the first place it should give the 5 variable in here, and then the value of the 5 should be preserved by the programs. Okay, and so if we run this program again, and so the 12 in here and 12 in decimal is equal to 1 1 0 0 in binary selection. Okay, and so we create these things in order to like this one. Okay, and so the 64 is equal to 64 in decimal is equal to 1000 is equal to the binary term of these things. Okay, this is our first example, and so we can give the much higher number in here, like this one, 1112, and so the binary number is given by these things, because we don't have to use this kind of variable in the integer value, like this one, 1 2 1 4, and so this term is related to the binary term of these things. Okay, because our codes is only related to up to 5 numbers. Okay, and so the 94A is related to 100010 is running on this time. Okay, and now we should create a, or we should pass the second example session in here, which is related to our coding techniques. This is included by the first example session. Like this one, x1 is in here, and so we need to create an x2 at the bottom of these codes. Okay, include standard input output h must be given in this time, and int main should be given in this time in order to run these codes properly. And so in the second question we will test how fast are computers. And so the question is that how can you determine how fast your computer really operates. And so in order to do that, we should use the while loop that counts from the 1 to 1 billion. Okay, and so every time the count reach a multiple of the 100 million, and so we should print our numbers, which means that our specific variable to the string. But in this question, use your watch to time how long each 1 million repetitions of the loop takes. And so in order to create a program by using these things, we should use the delay factor in here. We can utilize the programming language skills to obtain the correct time or the delay time or elapsed time of these things. Okay, you don't need to check the watch. And so if we have the programming skills in here, and then we can code, or we can write a code related to the measure of the elapsed time in our coding techniques. Okay, and so in order to create this example, we should assign a I variable in here with the type of the integer value with the initialization factor of the 0. Okay, and so this is the count variable in here, and so we can increase or decrease of this I variable in the program. And then we should give the some constants in here. The 1 billion can be represented by the 1 0 0 0 0 0 0 and 0 0 0. Okay, these are the 1 billion variable in here. Okay, and so the another constant in here, 100 million, can be represented by the 1 0 0 0 0 0 0 0 0. Okay, and so in order to calculate the elapsed time in the C program, and then we can use another library in here, which means that we have, or the compiler designer guys gives us a time header file in here. And so we can use the preprocessor, like the include variable in here, in order to include the time h in our programs. Okay, and so we can create a some specific type in here, clock t variable, in order to store the time variables. Okay, and so the clock t is a basic the long variable, but in order to use a meaningful representation, the long variable can be cast into the clock t by using the type def keywords. Okay, and so this is our notation, but this is the another representation of the time variable, because the long or the clock t can be used in order to get the full time variable in here, or the value of the time can be stored by using these things, or as well as the clock t variable. But in professional, we should use the clock t type in here. Okay, and so in order to calculate these things, firstly we should warn the user timer is being started in here with the new line characters, and then we should create a while loop in here. And so in order to create a while loop, we should use the keywords of the while, and then we should define a open and close parentheses in here. This is called the function calling operator, but in the main function block it's a open close parentheses. Okay, and so if we, what is our condition in order to run this while loop? This is given by the question, because 1 to 1 billion counts should be doing or should be done in our program. And so if e is smaller than 1 billion, and then we should proceed our algorithms. But in the first place we should update the e++. And so in every loop or in each iteration we should update, or we should increase the I value in here in order to count these programs. Okay, and so in the second place we have another condition in here. Every time the count reaches a multiple of 100 million, and so the print that number on the screen. And so we should check it by using the if blocks in here. And so if I remainder of the 100 million is equal to 0, which means that I is equal to 100 million, and so we should print out that the %d new line characters with e parameter in here. Okay, and so if you run this program, and then we can test it, and so in each iterations it's written, but the clock is not on the screen. And so in order to get the CPU clock, and then t must be equal to clock function. The clock function returns the what? The CPU time of your computers. Okay, and so if we get this tick variable in here, and then we can store these things as the t, or the clock t start in here, clock t end in here. There are two variable in here, and so t end must be equal to what? And so if we check the clock in here, but after the doing the loop variable in here, and so we have the time elapsed. And so if we have the clock function in here, and so we should call the again, but with the minus of the t start variable. Okay, and so the clock, for example, in here 0.001, and so the clock is in here the 0.004, and so t start is assigned in the first place. And so if we get the minus variable in here, 0.001, and so the total elapsed time for doing the while loop is equal to 3 or 0.3 milliseconds or the 3 microseconds. Okay, and so this is how we can calculate the, or we can measure the total elapsed time for our while loops. Okay, and so but this t variable or the clock variable does not in the form of the seconds, and so we should convert it the what time elapsed in here, we should convert it to seconds units. And so in order to do that, so the t end variable firstly casted with the double variable in here, and so in order to convert the CPU time into the second variable, and then we should use the clocks per second. This is the predefined clock variable. Is the compiled by the compiler or the guys that writes the C programming language, and so we can use it. Okay, and so after that the time elapse is in the unit of the seconds. Okay, and so in the end of this code we should write down the program took %f is related to the double type of C programming language, and so we have the seconds units in here, and to execute can be given in here, and so time elapsed can be given to the printf function. And so if we run this program and then the timer is being started, and at the end of this program the program took the 4.62 seconds in order to create or in order to do the whole this process. Okay, and so if we increase the 1 billion to 2 billion, and so this time is higher than the previous one. Okay, like this one. And so the 9 times or 9 seconds should be done in order to write or in order to loop or in order to create an iteration in our algorithm by using the while loops. Okay, and so this is our program, and you can compare the performance of your codes in terms of the time elapse or the sampling time period in our engineering approach. Okay, and so timer is being started and then timer is being ended can be given in here, and so if you rerun this program and then the timer is being ended. Okay, new line should be given in here in order to get the full picture of these things in clear terms. And so the program took 4 times 64 seconds. Okay, and so in the while loop we get these things, but what happens if we use the for loop in order to create this pattern? And so we can easily test these things like this one. If we create a for loop variable in here, the I is equal to 0, it's the initialization term, I is smaller than 1 billion is a condition, and so we can delete all these things. You can use the for loop like this one, and so if you don't know how to use this for loop, you don't worry about that because it's not relevant in our lesson. That's only our concern is to get the clock variables, okay, or the time elapsed variables. And so E must be increased by using these things. And so if I percentage or reminder term 100 million is given in here is equal to the 0, and then the each iteration should be printed one like this one. Okay, and so in the first place we should check the while loop iteration based on the clock or time elapsed period. But what happens if we use the for loop? And so if we rerun this program and then the program took the 4.62 seconds to execute, okay, but this is the for loop application, and so we can increase the code operation in here, T and T clock, and so we can set the for operation in here, T start 4, T start 4, T end 4, and so in this case we should create this pattern like this one. Okay, and so what happens if we use these two codes is iterated at the same time in our code representation. And so T start 4 is clock in here, and so T end must be placed by using these things, and so T we should create two more variable in here, T start while, T end while in here, and so these are for loop variation. And so if we measure the T start while loop, we should proceed with this one. The clock must be written in here, and so T end while loop is equal to T clock variable in here with the minus of T start while. And so in this time we can check both to for and while loop clock variable or elapsed time. Okay, and so we can create elapsed for with the definition of the T end 4, okay, seconds to execute for loops in here. But if we copy off these things by means of the while loop, and this is equal to while variable, and so this must be replaced by using these things, and so while can be checked by using these things. Okay, and so if we rerun this program and then 1 2 3 4 is given by in here, okay, this is also a ludicrous position because the E is going to do 1 billion, and so this loop cannot be run because the E is not smaller than 1 billion, and so in the first place we should assign the E is equal to 0 in this time. And so if you rerun this program and then both algorithms in here, okay, and so as you can see the for loop is much higher, the fastest algorithm in our study. The for loop is running in the 4.24 seconds, but the while loop 4.60 seconds. And so you can rerun this program, you can retest your program in here in order to get more knowledge of these things. And so the for loops is always the fastest algorithm or loops than the while loops, as you can see. Okay, and so in this week this is the last example in here. I hope you learn about how to use the clock variable or how to use the binary decimal integration or conversion operation in this time. And so in the next weeks we will see, or we will proceed to another examples of the C programming language lesson.